Our introduction for mixture word problems. Remember that all the notes are posted on the website, so you could print these out. It would save you some time and headache. As I go through here, I apologize because I am going to be moving this paper back and forth. I know it makes it a little bit hard to follow. That's why I'm saying you could print these things off and it'd be easier just to have that in front of you as I read through this. Mixture problems. There are 3 column headings that should be remembered when completing tables for mixture problems. The first is reserved for the ingredients. So I look down here, I have ingredients. And the next 3 columns will always have the same headings of amount, price or percent, and total. The amount will identify either a weight or a capacity. The last cell for this column is found by adding the individual ingredients. Oftentimes the mixture cell will be given and the ingredients can be declared using the process discussed in the last section using the concept of the sum of 2 numbers. We're talking about right here. You oftentimes will be given this mixture. Like if I say that this is 50 kilograms, you break this down into X and 50 minus X. Every once in a while you'll be given the actual values here. Maybe I say there's 50 kilograms of walnuts and 100 kilograms of cashews, so 50 and 100 would be 150 for the mixture. Just remember that this column is always an adding column to go up and down. For the second column, we're talking about price or percent. Price or percent, and in many cases, these values are given to the reader point blank. The last cell for this column is normally found to fall between the individual ingredient amounts. So if I have prices here, if I say that walnuts are selling for $10 and cashews are selling for $15, I expect something to fall between 10 and 15 in this last cell. This cell must fall between those individual cells there. That's what we're saying there. And the last thing that we want to talk about, the total. The last column can be found by multiplying cells horizontally for both amount and price or percent. Additionally, the equations are often found by adding the totals for each ingredient and setting the result equal to the last cell under this column heading. This is the reason for the hash marks on the last line in the table. It helps identify the equation. And again, what I'm trying to say there is, once you have values in here and here, you multiply horizontally to find a value here for the total. Multiply horizontally to find a value for the total. And the same down here. And I'm going to jump back to something that we've already worked with. If you consider the ticket problems, a lot of times we talk about the adult and then the student for essentially what would be the ingredients here. If I have adult tickets and student tickets, I figure out the number of tickets sold for each and the price for each to get to the total column. So if I had 5 adults and tickets cost $5, 5 adults at $5 would be $25 that was brought in. For students, if there were 50 students at $2, 50 times 2 would be $100 brought in. And then you would add that up to get your total. Well, algebraically, we don't necessarily know the exact dollar amount here, or even here for that matter. So a lot of times our equation comes from here. We would take ingredient 1 plus ingredient 2 equaling the total. Our first example for a mixture problem will be as follows. I'm going to read through it and I'm going to show you how I fill in the values. It says, walnuts that cost $4.05 per kilogram were mixed with cashews that cost $7.25 per kilogram. How many kilograms of each were used to make a 50 kilogram mixture costing $6.25 per kilogram? Round your answer to the nearest tenth. Okay, so first time you read through, you basically are looking for your ingredients. I already typed this in. I said walnuts, cashews to make a mixture. And then you want to start placing values. So I break this down, I read real slow and see what I can do with each value. It says walnuts that cost $4.05 per kilogram. That means I can go to the price and I can put 4.05 as a price per kilogram for walnuts. We're mixed with cashews that cost $7.25. So for the row of cashews, I can put $7.25 here. How many kilograms of each, that's my question, were used to make a 50 kilogram mixture? Well, under kilograms, mixture, I'm going to put the 50 here And as we've done so many times already, just like a ticket problem, I can break this down into W and then the number minus the variable. So W and 50 minus W. So that if this adds up, the variables drop out and I get that 50 mark. And it says that the mixture is going to sell for, or rather cost, $6.25. As we look at this, does the $6.25 fall between those two values? Since it does, you should feel pretty comfortable about putting $6.25 right there. Once I have the two columns filled out, it's time to multiply to get across the columns. And so in this first cell, I can call this 4.05W. On the next one, I'm going to go ahead and multiply. If I take 7.25 times 50, I get 362.5 minus 7.25W. And then for the last cell, I'll take 6.25 and multiply by 50. That gives me 312.5. And as I've said so many times, your equation is going to be found right here. You can take your ingredients, add them together, and set it equal to your total value. In other words, I can say the total cost for the walnuts plus the total cost for the cashews should equal the total cost for the mixture. So there's my broken English, there's my structure for the equation. Total for the walnuts plus total for the cashews equal the total for the mixture. As I place these values together, I can say 4.05W plus 362.50 minus 7.25W equal 312.50. Again, if you get confused here, in this second cell for the totals, I went ahead and distributed the 7.25 across that so that it saved me the work when I was writing my equation. It was already distributed. And at this point, I just need to combine like terms. So if I take the 4.05 minus the 7.25, that takes me to negative 3.20W plus 362.5. Sometimes it's nice to have that calculator because then you don't want to deal with all these decimals. My next step would be to move the 362.5 over. I know in class I always tell you make that variable positive, but for this one I'm just going to go ahead and move this over, and that will make a negative here. So I get negative 3.20W. Now this doesn't bother me because I'm expecting negative versus negative. When I divide out, that'll become positive. And this is negative 50 here. As I divide by negative 3.20, that creates W equaling 15 5/8. But remember, the direction said to round to the nearest tenth. So when I put that in my calculator, give me a second, I have to type that in. That's going to be 15.625, and so I'm going to call that 15.6. It tells me that W equals 15.6. And now as I try to answer this, I have to come back to this column, and I'll say walnuts equal 15.6 kilograms. And the cashews would be 50 minus 15.6, which is 34.4 kilograms. And as always, we want to put that in a box. That's what I was writing here. Walnuts, 15.6 kilograms. Cashews, 34.4 kilograms. And there's your first example for how to do a mixture problem. Almost every one of them will be set up the same way. We just change ingredients. Sometimes instead of doing dollar amounts, we do percents. And so you'll want to look at the next couple videos where sometimes I call this a percent. And then if I do a percent, I don't have any decimals here. Other times I might call it cent. And so if I do a cent, that means there would be no decimals here, and I would turn this into 405, 725, 625. The only catch is if you turn this into a cent and I would happen to give you this value here, you have to remember to move that over 2 decimal places as well, because everything must match in terms of the units. Good luck to you, and we'll see you in class.